What if I told you that everything you think you know about size, about distance, about the scale of reality itself is completely wrong? Right now, as you sit here listening, beams of light are racing toward you at 670 million miles per hour from stars that burned out before Earth even existed. The universe is not just big. It's not just vast. It's so far beyond human comprehension that the very word big becomes meaningless. You believe you understand what enormous means because you've seen skyscrapers stretch into the sky or flown across oceans that seem endless. But those are illusions, tricks of perspective shaped by a fragile human brain that evolved only to measure the distance to the nearest river or the size of a mammoth. When you begin to step outside that tiny window of experience, your sense of scale shatters like glass. Picture this. The ground beneath you feels solid and permanent, but in reality you're standing on a ball of rock hurtling through space at 67,000 miles per hour, spinning like a toy top while orbiting a star that itself is tearing around the galaxy at 500,000 miles per hour. And yet, all of that staggering speed and motion is happening inside something so massive that you can't even begin to imagine its full size. If Earth were shrunk down to the size of a marble, the entire solar system would barely cover a city block, and even then, that city block would be just one forgotten corner of a single neighborhood in a sprawling metropolis of galaxies. We live our lives thinking our planet, our countries, our oceans are huge, but compared to what's out there, they don't even qualify as a speck of dust, they vanish. And once you realize just how small everything you know really is, the universe opens up before you like a labyrinth of impossible scales, each step pulling you further into a reality that seems designed to overwhelm the mind. You think of Earth as enormous because that's the only perspective you've ever known. Flying across a country takes hours, a trip to another continent takes most of a day, and crossing an ocean feels like venturing into infinity. Walking across a city, driving across a state, these are the anchors your brain uses to define what big means. But here's the brutal truth. Our planet, the very ground you think of as vast and endless, is so insignificant in the larger picture of existence that calling it small would be an insult to the word. Imagine shrinking everything you've ever seen, every building, mountain and continent down into a single marble. Before you've even made it beyond your cosmic backyard, that marble is already too tiny to see. Earth is not the center of anything. It's not the anchor of reality. It is a vanishing point, a dust grain lost in a cathedral of impossible size. Stand outside on a clear night and look up. The stars feel distant, but your mind tricks you into thinking you can somehow grasp what that distance means. Far for you is a few thousand miles in an airplane, or maybe a few hundred miles on the highway. But the moon, the closest celestial body in our night sky, sits more than 240,000 miles away. That's 10 Earths stacked in a line, end to end, and still not enough to reach it. Yet from here, you can block out the moon with a single thumb held at arm's length. That's the illusion. Your brain never evolved to handle millions or billions of anything. To a hunter-gatherer's survival-focused mind, 1,000,000 and 1,000,000,000 feel the same, just a lot. But the difference is not just large, it is staggering beyond reason. 1,000,000 seconds pass in about 12 days, 1,000,000,000 seconds pass in 32 years, and that's only time. When you apply that scale to distance, everything collapses. If Earth were a marble, the entire solar system, the planets, moons, comets, and the sun itself, would be smaller than a single city block. Think about what that means. You could walk across a block in minutes. That's your whole solar system. And then realize that our solar system is nothing but a pinprick of light inside a galaxy of 400 billion stars. Each of those stars might have its own planets, its own marbles, its own small worlds where people wonder if they are large and important. And those galaxies, they aren't scattered sparsely. They are stacked and layered across the universe in webs and walls that stretch farther than human imagination can reach. The ground beneath your feet, the soil, the cities, the mountain ranges, none of it is big. It only feels big because you are small. When you step outside and feel the permanence of the earth beneath you, remember this. You're standing on a thin crust wrapped around a molten core, a ball of rock spinning wildly through space at 1,000 miles per hour, while orbiting the sun at 67,000 miles per hour. You don't feel that speed because you're moving with it, locked to the planet like an insect stuck to a racing car windshield. But if you could suddenly freeze the universe around you, you'd see Earth hurtling through the void with terrifying velocity, and still that velocity wouldn't even begin to register compared to what's next. We call mountains massive. We treat oceans like endless frontiers, but from space they barely register as wrinkles. Mount Everest, the highest peak on this planet, is just 5.5 miles high. Stack 11 Everests, and you've only just reached the edge of space. 11. That's it. Take that further. The atmosphere that keeps you alive, every breath you've ever taken, every cloud that's ever floated above your head, every storm, every rainbow, exists within a razor-thin shell hugging Earth's surface. If you shrank Earth down to basketball size, that entire atmosphere, the air we depend on, would be no thicker than a sheet of paper wrapped around it. That's not vast. That's fragile. That's terrifyingly small. And that's the scale of our world before we've even left the driveway of the universe. The illusion of size doesn't stop there. Most people believe Earth dominates their reality. But compared to the Sun, it is practically invisible. The Sun could swallow over 1 million Earths and still have room left. Light, the fastest thing in the universe, takes just 1/17th of a second to circle Earth. But to cross the Sun's surface, it needs more than 4 seconds. Think about that. The very thing that powers our world and makes life possible could consume us without effort, and yet astronomers call it average. It's a background star, a yellow dwarf, and in the context of the galaxy it barely matters at all. But here's where your sense of scale collapses completely. We treat the solar system like an endless expanse. But the truth is we haven't even stepped outside the neighbourhood. Humanity's greatest achievement in exploration, the International Space Station, sits only 250 miles above Earth. That's closer than the drive from New York to Washington, D.C. Our entire species has managed to travel less than the distance of a weekend road trip into space, and we act as if we've touched infinity. The farthest humans have ever gone is the Moon, 3 days by rocket, and even that world is still chained to Earth's gravitational field. Pluto, the distant outpost we used to call a planet, orbits 3.7 billion miles away. Light itself needs more than 5 hours to reach it. That sounds enormous, until you realise that Pluto marks only the shallow edge of the real boundary. Beyond it stretches the Kuiper Belt, then the Oort cloud, a sphere of icy objects extending halfway to the nearest star. That's the scale of just our solar system, and even then it's still nothing. Now stop and realise how fragile your perception of big has become. Your house, your city, your entire country. These things shrink to invisibility when compared to Earth as a whole, but Earth shrinks even faster. Within our solar system it is barely noticeable. Within our galaxy, it disappears altogether. And within the observable universe, Earth doesn't even qualify as a rounding error. Our planet is smaller than the smallest pixel on the grandest screen you can imagine. All the wars ever fought, every empire, every love story, every human life, all of it happened on this speck. To call it tiny is to exaggerate its importance. And yet, this is where we live. This is what we call home. The illusion of Earth size makes it feel permanent, solid, enormous. But once you strip away the limits of human perspective, it becomes clear that our world is less than a whisper in the cathedral of the cosmos. Every step you take across a city, every plane ride that feels endless, every ocean voyage that stretches for weeks, all of it is happening on a world that doesn't even make a dent in the fabric of space. We are dust thinking itself large. We are atoms pretending to own infinity. And once that realization sinks in, there's no going back. You can never see Earth the same way again. From the ground, the sky feels endless. You look up on a summer afternoon, see clouds drifting higher and higher, and it seems like they could go on forever. On a clear night, the stars stretch into infinity, and the dark canvas above your head looks like it has no edge. Your brain interprets that as vastness. It convinces you that Earth's sky is boundless, that above us lies a limitless ceiling. But the truth is far more humbling and much more fragile. Our atmosphere, the thin veil that keeps every one of us alive, is so delicate that if Earth were the size of a basketball, that entire sky, the oxygen, the storms, the jet streams, the layers of protective gases, would be no thicker than a single sheet of paper wrapped around it. That's it. That thin layer is the only thing separating the warmth of life from the freezing emptiness of space. Everything you've ever known about the sky, every breath you've ever taken, every storm that's rolled over your city, every rainbow you've stopped to admire, every hurricane, every snowstorm, all of it happens in just the lowest layer of that paper-thin film. 99% of the atmosphere's mass is below 30 miles of altitude. Think about that for a second. Mount Everest, the tallest peak on Earth, is just over 5 miles high. Stack 6 Everests on top of one another and you'd still be below the majority of the atmosphere. The jets that roar across the sky on your way to another continent, they fly at about 7 miles up. That's nothing. They're skimming along the very bottom edge of the atmosphere, dipping into the lowest pocket of that paper-thin blanket. From the ground, it feels limitless. From space, it's laughably fragile. This razor-thin shell is all that stands between life and annihilation. Without it, liquid water would boil away, ultraviolet radiation would sterilize the surface, and cosmic rays would strip DNA apart in seconds. It is the filter that shields us from meteors, burning most of them into harmless streaks before they hit the ground. It is the protective layer that blocks deadly solar radiation, scattering sunlight into the blue sky you see every day. Yet compared to Earth itself, the atmosphere is so thin that calling it delicate barely captures the truth. It is a fragile bubble, and life clings to the inside like condensation on glass. When astronauts reach low Earth orbit, they describe something called the overview effect. They look back at Earth, and suddenly the atmosphere doesn't look endless. It doesn't look like a towering wall of sky. It looks like a soft, glowing line, so thin it could vanish if you brushed it with your hand. The black of space presses right up against it, and you can see, with your own eyes, how vulnerable everything truly is. That line, thin, glowing, fragile, is where all of human history has unfolded. Every empire, every war, every love story, every invention, every triumph and every tragedy, every one of them has happened within that fragile skin of air. And when astronauts see it, many of them say the same thing. They feel both awe and fear. Awe because it is beautiful. Fear because they realize how easily it could be gone. Consider this. Earth's atmosphere isn't even permanent. It leaks. Bit by bit, atom by atom, gases escape into space. Over billions of years, the planet has lost enormous amounts of hydrogen and helium. We don't notice it day to day, but the reality is that our protective bubble is constantly bleeding away. If Earth didn't have its magnetic field, a shield generated by molten iron churning in the core, the solar wind would have stripped our atmosphere bare long ago. That's exactly what happened to Mars. Billions of years ago, Mars had rivers, lakes, maybe even oceans. But without a strong magnetic shield, its atmosphere was blasted away by the sun. Now it's a frozen desert. And when you compare the thin line of Earth's sky to the lifeless expanse of Mars, you realize just how fragile, just how temporary our own protection really is. Even within this delicate shell, life only clings to the lowest portion. Birds, insects, and humans breathe oxygen that's confined to a sliver of the atmosphere. 90% of humanity lives below 6,000 feet. Go higher, and the air thins so quickly that you need machines or training to survive. At 15,000 feet, oxygen levels are already so low that many people faint or become sick. Above 30,000 feet, without a pressurized cabin, you would black out in minutes. At 60,000 feet, your blood would begin to boil at body temperature. That's barely above the cruising altitude of fighter jets. Space isn't some distant realm you'll never reach. It begins shockingly close. The line between breathable life and vacuum is not a distant frontier. It's right above your head, so close that if you could drive straight upward in a car, you'd be outside the protective blanket in less than an hour. That thin film also acts like a lens. It bends light, filters radiation, scatters energy, and even changes what you see when you look at the stars. Without it, the night sky would blaze with unfiltered light from billions of stars. Sunsets wouldn't glow with orange and red. The sky wouldn't shine blue. The atmosphere doesn't just keep us alive, it creates the world we know. And yet, because it's so thin, so fragile, so precarious, we treat it like it's indestructible. We pump it full of carbon, methane, and pollutants. We punch holes in the ozone, disrupt its delicate balance, and assume it will always protect us. But when you zoom out, you realize how insane that assumption really is. We are tampering with the single most delicate thing that makes life on Earth possible, and compared to the universe around us, it's practically invisible. The next time you step outside and feel the wind on your face, think about what it actually is. Molecules of nitrogen and oxygen colliding with your skin. Those molecules are rare, precious, and they are only here because of billions of years of chance and stability. The atmosphere is not a fortress wall. It's a soap bubble shimmering in the cosmic dark. All of life exists inside it, pressed into a layer thinner than the peel of an apple compared to the fruit beneath. Without it, there is nothing. With it, there is everything. And once you understand just how fragile this bubble is, you start to see the sky differently. You stop thinking of it as endless. You start realizing that it could be gone, that it depends on balances so precise, so razor thin, that one change could tip the scales. Earth feels huge. The sky feels infinite, but the truth is merciless. We are living inside a fragile paper shell, clinging to the smallest margin between survival and oblivion. And right above that shell, just a breath away, lies the unending void. When people think about space travel, they imagine rockets blasting into the void, astronauts disappearing into the unknown, and spacecraft traveling unimaginable distances. Movies and documentaries make it seem like a leap into another world, as though the International Space Station floats in some distant corner of the universe. But the truth is almost laughable in its contrast. The International Space Station, the crown jewel of human spaceflight, the place we picture as far beyond reach, is actually shockingly close. If you could somehow climb into your car and drive straight upward at highway speed, you'd reach it in less than 2 hours. That's shorter than a weekend drive from New York to Washington, D.C., or from Los Angeles to San Diego. Humanity has been launching people into orbit since 1961, and in all that time, we've never gone farther than 250 miles above the surface on a regular basis. 250 miles. That's a morning commute in some parts of the world, and yet we call it space. It's almost comical when you realize that the farthest most astronauts have traveled is closer to you right now than the nearest major city. The ISS is not hanging in some mysterious corner of the cosmos. It's barely skimming the atmosphere, orbiting Earth every 90 minutes, fast enough to see 16 sunrises and 16 sunsets in a single day. From the ground, it looks like a bright dot streaking across the night sky, vanishing just as quickly as it appears. That dot holds a laboratory the size of a football field, where astronauts conduct experiments in zero gravity and test the limits of human survival in space. But when you measure the distance, it's humbling. The ISS is closer than most people's vacation destinations, and yet despite being so close, it might as well be another universe. Only about 600 humans in all of history have ever been there. Out of 8 billion people, a handful have looked down and seen the curve of Earth with their own eyes. Think about that. Statistically, the chance of you visiting orbit is essentially zero. More people have summited Mount Everest. More have crossed the Sahara. More have set foot on the icy plateau of Antarctica. Space, even this thin sliver just above us, remains off-limits to nearly all of humanity. That in itself should shatter your sense of what's accessible. Something so close, so near you could drive to its altitude, is still locked away like a forbidden world. What makes this even more fascinating is the speed at which the ISS moves. To stay in orbit, it has to travel at 17,500 miles per hour. That means every 90 minutes it completes a full circle around the Earth. In the time it takes you to watch a movie, astronauts inside the station have travelled over 25,000 miles. When they look out the window, they don't see a slow crawl across the continents. They see cities and landscapes whipping by in minutes, oceans stretching and vanishing in less than an hour. Sunrise doesn't creep into view. It explodes across the horizon 16 times a day. And yet, from our perspective on the ground, the station moves like a star drifting slowly across the night sky. The disconnect between speed and perception is another reminder of how fragile our sense of scale truly is. Consider this too. The ISS is both permanent and temporary. It has been continuously occupied since the year 2000, a remarkable achievement in human cooperation and engineering. Astronauts from all over the world live and work there, representing nations that often compete fiercely on Earth. Up there, the borders vanish. There are no countries, no cities, no politics when you look down at the glowing blue sphere below. There's only Earth, and the thin, glowing line of atmosphere that keeps it alive. Many astronauts speak of the overview effect, a psychological shift that happens when they see the world from orbit. They describe a sudden understanding that everything we fight over, the lines we draw, the flags we raise, are illusions compared to the fragility of our planet. From up there, Earth looks small, it looks unified, and perhaps most of all, it looks vulnerable. But here's the catch. As astonishing as the ISS is, it represents the barest baby step into space. Orbit is not far, it is not deep, it is not even the beginning of the universe beyond. It is a tiny, fragile foothold clinging just above the surface of our world. Beyond it stretches a vastness so immense that even our fastest spacecraft struggle to scratch its surface. The ISS is like climbing to the top branch of a tree and calling yourself an explorer of the forest. It's impressive, yes, but it's also humbling. We haven't even left the backyard. Even the moon, which sits just 240,000 miles away, feels unreachable compared to orbit. The Apollo missions of the 1960s and 70s remain the only time humans have truly left Earth's gravitational cradle. 12 men walked on the lunar surface, and in doing so, they reached a distance 1,000 times farther than the ISS. And yet, in the half-century since, we haven't returned. Our boldest step outward stalled after a handful of missions, leaving us confined to a thin bubble of orbiting labs and satellites. The ISS may be close, but symbolically it highlights the incredible gulf between our dreams of the stars and our actual achievements. Think about this. While we celebrate astronauts floating 250 miles above Earth, light itself crosses that distance in just over a millisecond. A single blink of your eye takes about 300 milliseconds. In that time, light could have travelled from Earth to the ISS and back 150 times. That's how close it is. That's how little we've managed to reach. And yet, when you compare even that minuscule leap with the true scale of the solar system, it's nothing. To get from Earth to Mars at its closest is more than 33 million miles. To reach Jupiter, it's hundreds of millions. To reach the nearest star beyond the Sun, it's 4 light years, 25 trillion miles. And in that context, orbiting 250 miles above the surface isn't just small, it's microscopic. But don't mistake this perspective for dismissal. The International Space Station is proof of what humanity can do when it pushes beyond the ordinary. It's proof that we can survive, adapt, and thrive outside the comfort of our home planet, even if only just barely. It's proof that fragile human bodies can endure weightlessness, radiation, and isolation, and still conduct science that reshapes our understanding of biology, physics, and medicine. It may be close, it may be small, but it represents the first rung of a ladder that could one day stretch to the stars. The ISS is humbling in its limits, but inspiring in its existence. So the next time you hear about astronauts floating in orbit, remember the paradox. They are closer to you than the next big city, yet separated by barriers more unforgiving than anything on Earth. They live in a world that you could reach by car in 2 hours if only gravity would allow it, and yet fewer than 1,000 humans have ever crossed that threshold. It is a place that feels distant and unreachable, and at the same time startlingly near. It is proof that space is not as far as you think, and a reminder that even our greatest achievements are just the beginning. Because once you realize how small orbit really is, the next question becomes impossible to ignore. If this is all we've managed in 60 years of spaceflight, what lies beyond it, waiting for us to discover? When you stand outside on a bright summer day, the sun feels overwhelming. Its light warms your skin, its glare forces you to squint, and on the hottest afternoons it can feel like a merciless weight pressing down on you. It seems massive, unstoppable, eternal. But the truth is that the sun is so far beyond what your senses can comprehend that even imagining it as big is a failure of language. Right now, at this very moment, the sun is fusing 600 million tons of hydrogen into helium every single second. 4 million tons of its own mass vanish into pure energy in that same heartbeat. That energy streams across space in all directions, travelling 93 million miles to reach Earth. And when it finally arrives, just 1 fraction of 1 billionth of its total output is enough to power every living thing on this planet, every forest, every ocean current, every heartbeat. That's how much energy it has to spare. Imagine lining up Earth beside the Sun. It would take more than 1,000,000 Earths to fill its volume. You could drop our planet into the Sun over and over and it would swallow them without a ripple, without even noticing. The sheer immensity of it defies comprehension. If the Sun were hollow, you could place 100 Earths side by side just to stretch across its diameter. Every single second, the Sun outputs more energy than all of humanity has ever consumed in our entire history combined. And yet astronomers don't treat it like something special. They don't look at the Sun with awe in their equations. To them, it's nothing more than an average star, a yellow dwarf. The kind of star you could find scattered by the billions across the Milky Way. That's perhaps the most unsettling part. Something that to us is unimaginably vast, unimaginably powerful, is, on a cosmic scale, just ordinary. Light, the fastest thing in the universe, takes just over 8 minutes to travel from the Sun to Earth. That means every sunrise you've ever seen, every ray of warmth you've ever felt on your face, left the Sun minutes earlier. When you step outside, you're not feeling the present, you're feeling the past. And yet, as close as the Sun feels to us, its scale is so enormous that its surface, its seething ocean of plasma, could take light more than 4 seconds to cross. 4 seconds just to skim across its face. From here, it seems small, a neat disk in the sky, something you can block out with your thumb. But that disk is a blazing inferno 100 times wider than our entire planet. The illusion of size once again hides the truth. Look closer, and you'll see that the Sun isn't a smooth sphere. It's alive, seething, boiling, throwing up eruptions larger than Earth itself. Solar flares burst outward with the force of millions of nuclear bombs, and coronal mass ejections hurl billions of tons of charged particles into space. When those particles reach Earth, they can disrupt satellites, black out power grids, and paint the sky with auroras. The most violent solar storms in history have knocked out telegraph systems, fried transformers, and nearly shut down entire electrical networks. And yet to the Sun, these storms are nothing more than tremors. They are tiny ripples on a surface boiling with nuclear fire. But as colossal as it seems, the Sun is still only in the middle of its life. At 4.6 billion years old, it has burned through less than half of its hydrogen. It will continue shining for another 5 billion years before swelling into a red giant, consuming Mercury and Venus, and possibly swallowing Earth itself. In that stage, it will expand hundreds of times its current size, its surface glowing red as it engulfs everything in its reach. Imagine the sky filled not with a small bright disk, but with a star so massive it stretches from horizon to horizon. For billions of years, life has relied on the Sun's steady warmth. One day, that warmth will turn into fire, and the star we see as constant and unchanging will become a monster. Even then, in its death throes, the Sun won't be remarkable. Other stars dwarf it on scales that are almost impossible to put into words. Take Betelgeuse, for example, a red supergiant in the constellation Orion. If you placed it at the centre of our solar system, its surface would stretch past Jupiter. Our Sun, which could consume 1,000,000 Earths, would look like a spark next to Betelgeuse's furnace. Or consider UY Scuti, one of the largest stars ever measured. Its radius is more than 1,700 times that of the Sun. Drop it in place of our star, and its edges would engulf the orbit of Saturn. When you compare the Sun to stars like these, it doesn't seem immense anymore. It seems small, almost fragile. That is the paradox of scale. Something that dominates your entire existence is itself dominated by others beyond it. The Sun gives you life, defines your days, sets your seasons. Without it, Earth would be a frozen wasteland in less than a week. And yet in the grand theatre of the galaxy, it doesn't even earn a mention. Astronomers look at stars like our Sun and shrug. They catalogue it as one more data point among billions. When you stand on Earth, the Sun feels infinite. When you zoom out, it is ordinary. What's most astonishing is that even with all its power, all its mass and all its energy, the Sun is not the centre of the universe. It's not even the centre of the galaxy. It orbits something greater, drawn by the gravity of billions of other stars. And in that orbit, it carries us along, dragging Earth and everything we know through the galaxy at more than 500,000 miles per hour. The Sun isn't stationary. It's not sitting like a god in the middle of the cosmos. It's racing, burning, moving, pulled by forces larger than itself. And compared to the galaxy, compared to the universe, it too vanishes into insignificance. So the next time you step outside and feel the sunlight on your face, remember this: you're feeling the byproduct of nuclear fire that consumes millions of tons of matter every second. You're standing on a world powered by a star so immense that it makes Earth look microscopic, and yet so average that in the cosmic ocean it barely registers. The sun is both everything and nothing. It is the force that sustains you, the furnace that fuels life, and at the same time, it is just another flickering ember in a sky filled with countless others. It dominates your world, but it does not dominate the universe. And once you grasp that paradox, once you understand the scale that dwarfs even the sun, you realize that our journey outward has only just begun. When most people think about the edge of the solar system, they think of Pluto. For decades, school children learned to recite its name at the end of the list of planets, a lonely frozen rock drifting on the outer rim of our neighborhood. In the human imagination, Pluto became the marker of the frontier, the last stop before the great unknown. But the truth, as always with the universe, is far stranger and far larger than we were taught. Pluto is not the end. It is barely even the beginning. What lies beyond it makes everything we think of as distant seem impossibly close. Pluto itself is a strange little world. Discovered in 1930, it was celebrated as the 9th planet, until scientists realized it didn't quite fit. At just over 1,400 miles across, Pluto is smaller than Earth's moon. If you were standing on its surface, the horizon would curve away far quicker than it does here, making the world feel cramped and small. The sunlight would look dim and faint, like a late afternoon glow that never quite becomes bright daylight. Temperatures plunge to nearly 400 degrees below zero, cold enough to freeze not just water, but nitrogen and methane into ice. Its atmosphere is so thin that it collapses and falls to the ground when Pluto drifts too far from the sun, then reforms when it comes back around on its 248-year orbit. Everything about Pluto screams fragility, distance, desolation, and yet, compared to what's beyond, it is almost cozy. Pluto orbits within a region called the Kuiper Belt, a vast ring of icy bodies that circles the sun far beyond Neptune. This belt stretches billions of miles, filled with remnants left over from the solar system's birth. Dwarf planets like Eris, Haumea, and Makemake drift in this frozen expanse, along with countless smaller objects. If Earth and the inner planets are the crowded, warm living room of the solar system, the Kuiper Belt is the dark attic cluttered with forgotten relics. And beyond even that attic lies the Oort cloud, an almost mythical sphere of icy debris extending trillions of miles in every direction. That cloud is so vast that it may stretch halfway to the nearest star. Imagine a bubble of comets surrounding the solar system, a bubble so large that it would take a spacecraft travelling at tens of thousands of miles per hour tens of thousands of years to cross it. That's the true boundary of the solar system, and Pluto is just the doormat. To put it into perspective, if you shrank the solar system down to the size of a grain of sand, the nearest star would still be a mile away. That's how much empty space lies between us and our neighbours. Pluto feels distant because it's billions of miles from Earth, but compared to the scale of the galaxy, it's barely a step across the driveway. We treat it like a frontier, but the real frontier begins beyond the places we can even imagine reaching. Consider how long it takes light to travel. From the Sun to Earth, just over 8 minutes. From the Sun to Pluto, more than 5 hours. If you were on Pluto and looked back at Earth through a telescope, you wouldn't see it as it is right now. You'd see it as it was more than 5 hours ago. Light itself, the fastest thing in the universe, takes nearly a quarter of a day to send a message from one end of the solar system to the other. And yet, even this enormous distance vanishes when you zoom out. The nearest star, Proxima Centauri, is over 4 light-years away. That's more than 26 trillion miles. Suddenly 5 light-hours doesn't seem so impressive. Pluto isn't the edge, it's a reminder of how small even the biggest numbers we can grasp really are. Spacecraft like Voyager 1 and Voyager 2 have given us glimpses of this scale. Launched in 1977, they flew past Jupiter and Saturn, capturing images that stunned the world. Voyager 2 went on to visit Uranus and Neptune, sending back pictures of pale blue planets, that no human eyes had ever seen. Both probes are now beyond Pluto, racing into interstellar space. But even after nearly half a century of travel at speeds of more than 30,000 miles per hour, they are still nowhere near another star. Voyager 1, the most distant human-made object, is over 14 billion miles from Earth, and it would still need more than 40,000 years to reach Proxima Centauri. Think about that. 40,000 years. That's longer than human civilization has existed. That's the timescale of evolution, not exploration. And that's just to reach the next star, the closest one in an ocean of billions. The Oort cloud, if it truly exists as scientists believe, is so vast that we've never seen its objects directly. Its comets drift in orbits that may take millions of years to complete. Some of them are disturbed by passing stars or the gravity of the galaxy itself, flung inward toward the sun to light up our skies as long-tailed visitors. Every comet you've ever seen, every icy wanderer blazing across the heavens, is a messenger from the deep outer reaches, a reminder that the solar system is larger, stranger, and darker than we imagine. Pluto is just a step into that darkness, and yet Pluto holds a unique place in our hearts because it marks the limit of what we once thought we could understand. For decades it was the lonely outpost, the tiny guardian at the edge of the map. The debate over its status as a planet is more than just scientific, it's symbolic. People don't like losing Pluto because it feels like losing the boundary, like admitting that the edge is far farther away than we want it to be. To demote Pluto is to accept that the solar system is vaster, colder, and emptier than our comfortable list of 9 planets once made it seem. And in truth, that's exactly the case. The edge is not at Pluto. The edge is in the unimaginable. So the next time you hear the name Pluto, don't picture it as the end of the road. Picture it as a signpost. Beyond it lies a frozen wasteland of ice and rock stretching billions of miles further. Beyond that lies a halo of comets so vast it defies numbers. And beyond that lies the endless void, where stars float alone in oceans of emptiness. Pluto is not the boundary. It's the reminder that boundaries themselves are illusions. The universe doesn't care about the lines we draw. It doesn't end where we want it to end. It stretches, endlessly, into silence. In 1977, humanity did something extraordinary. For the first time, we reached beyond the planets and hurled 2 spacecraft into the great unknown. Voyager 1 and Voyager 2 were small by cosmic standards, no bigger than a car, yet they carried within them the ambition of an entire species. They were sent to tour the outer planets, to give us our first close-up views of Jupiter, Saturn, Uranus, and Neptune. And they did. They captured storms raging on gas giants larger than Earth itself, revealed moons that were active and alive in ways we had never dreamed, and then, after finishing their grand tour, they kept going. They never stopped. They are still going. And yet, after almost 50 years of travel, they have only just begun to touch the outskirts of the vast cosmic ocean. Voyager 1, the most distant human-made object in existence, is now over 14 billion miles away. That sounds unfathomable, but when you measure it against the scale of the galaxy, it is barely a scratch. To give you perspective, if the Milky Way were shrunk down to the size of North America, Voyager would not even be past the first step off the sidewalk. It has left the solar system, crossing the heliopause, the boundary where the sun's influence fades into interstellar space. But even now it hasn't reached another star. It hasn't even come close. The nearest star system, Alpha Centauri, sits over 4 light-years away. That's more than 25 trillion miles. At Voyager's current speed, over 38,000 miles per hour, it would take more than 40,000 years to get there. 40,000 years. To put that in perspective, 40,000 years ago our ancestors were chiseling stone tools and painting on cave walls. Entire civilizations rise and fall in less time than it would take Voyager to cross that single distance, and that's just the nearest star. The galaxy itself contains hundreds of billions. Even if Voyager could somehow survive the ravages of time, even if it could continue forever, it would drift through a cosmos so empty and so vast that it might never come close to another world. Space is not crowded. It is not filled with stars bumping into one another like lights on a Christmas tree. It is a desert so empty that stars are separated by gulfs of pure nothingness, with distances so large that our minds rebel against them. Voyager is not racing toward another system. It is drifting into silence. And yet, despite this futility, Voyager carries with it something deeply human. Affixed to each spacecraft is the golden record, a copper disc etched with sounds and images of Earth. Greetings in dozens of languages, music from Beethoven to Chuck Berry, the laughter of children, the roar of thunder, images of landscapes, animals and people. It is a message in a bottle, cast into an ocean so vast that it may never wash up on any shore. The odds of another civilization ever finding it are vanishingly small, but the act of sending it is what matters. Voyager is not just a machine. It is a monument to curiosity, to the refusal of our species to stay confined to one world. It is proof that even in the face of impossible distances, we still reach out. But consider what that means. Our fastest spacecraft, travelling for half a century, has only just left the cradle of the sun's influence. It has not reached another star, and it will not in any timescale that matters to humanity. This is the humbling truth of space exploration. We have touched the surface of infinity, and it is so large that even our greatest efforts vanish. Voyager's journey is a reminder that the universe is not built for us. It is not designed to be crossed. It is not a map with convenient borders. It is a chasm so deep that even light, moving at 186,000 miles per second, takes years to cross from one star to the next. Voyager's speed, impressive as it is nothing more than a crawl compared to what is required. And yet, Voyager matters precisely because of that futility. It reminds us of scale. It shows us how tiny we are. When Carl Sagan persuaded NASA to turn Voyager's camera back toward Earth in 1990, it captured the famous pale blue dot image. From nearly 4 billion miles away, Earth appeared as a single pixel, less than a fraction of a point, a mote of dust suspended in a sunbeam. Every human being who has ever lived, every war, every empire, every discovery and invention, all of it was contained in that pale dot. That image shattered illusions of grandeur. It showed us not as rulers of the universe, but as children standing on a small rock, fragile and temporary. Voyager didn't just explore the outer planets. It forced us to confront our own insignificance. Even now, as it drifts into the dark, Voyager continues to send back faint signals. Its power is dwindling, its instruments are shutting down one by one, but it still whispers across billions of miles. A 20-watt transmitter, no stronger than a refrigerator light bulb, is reaching antennas on Earth with messages that have travelled more than 20 hours at the speed of light. That's how far away it is. A command sent today won't reach Voyager until tomorrow, and its reply won't come back until the next day. It is a ghost ship sailing through the dark, still tethered to us by the faintest of threads. Eventually those whispers will fade, its nuclear power source will run out, the last signal will die, and Voyager will become silent, drifting forever in interstellar night. But silence doesn't mean failure. Voyager will keep moving, even if we can no longer hear it. It will wander among the stars long after humanity is gone, long after Earth itself has been reshaped by time. In 5 billion years, when the sun swells into a red giant and consumes the inner planets, Voyager will still be out there, cold and alone, carrying its golden record, a relic of a species that once dared to dream. It may never be found, but it will exist, proof that for one moment in the history of the cosmos, creatures from a small blue world reached out and tried. That is the paradox of Voyager's journey. It is futile, yes, because the distances are too vast to conquer, but it is also eternal because it shows us what it means to be human, to look into the impossible and move forward anyway, to build a machine that outlives its makers and carries their voices into the void. Voyager's path is a reminder that exploration is not about reaching the destination. It's about refusing to accept boundaries, about sending a piece of ourselves into the unknown even when the unknown is infinite. So when you hear about Voyager drifting through interstellar space, don't think of it as lost. Think of it as a symbol, a fragile machine still carrying our story, moving endlessly into the dark. It will not reach another world in our lifetimes. It may never be found at all, but that's not the point. The point is that it exists, that it continues, that it defies the limits of our smallness. Voyager's futile journey is, in the end, not futile at all. It is the essence of what makes us human. The desire to step into the endless night, not because we know what's out there, but because we want to find out. The Milky Way is the galaxy we call home, but calling it home makes it sound small, manageable, something you could put on a map and trace with your finger. The truth is that the Milky Way is so vast that even using numbers feels meaningless. Imagine standing in a desert at night. No lights, no sounds, just the dome of stars overhead. Every point of light you see with the naked eye, every twinkling star is part of the Milky Way. And yet what you see is just the faintest dusting along the edge of something so colossal it almost breaks the mind to consider. Our galaxy contains hundreds of billions of stars, and it stretches 100,000 light-years across. To put that in perspective, 1 light-year is nearly 6 trillion miles. Multiply that by 100,000. That is the span of our home. Think of it like this. If the solar system, the sun and its planets, stretching out past Pluto and into the Oort cloud, were the size of a quarter, the Milky Way would be the size of North America. That's how little we matter within its expanse. Voyager, which has travelled farther than anything we've ever built, hasn't even left the driveway compared to the size of this continent. We live in a city of stars so massive that light itself, moving at 186,000 miles per second, takes 100,000 years to cross it. Imagine that. Hundreds of generations living and dying, entire civilizations rising and collapsing, all while a single beam of light makes its way from one end to the other. That is the true scale of the galaxy we inhabit. And yet, despite its size, the Milky Way has structure, a kind of order hidden within the chaos. At its centre lies a supermassive black hole called Sagittarius AR, containing the mass of 4 million suns. Around this core, stars orbit in dizzying swirls, bound by gravity so immense that even light cannot escape. The spiral arms radiate outward like the petals of a cosmic flower, each arm lined with nebulae, clouds of gas and dust where new stars are born. Between those arms are gaps, voids of relative emptiness, but even those voids contain more stars than the human eye could ever hope to count. Our own solar system sits far from the centre, tucked away in a minor spiral arm called the Orion Arm, like a forgotten suburb on the edge of a sprawling metropolis. We are not in the bustling downtown. We are on the quiet outskirts, barely noticeable against the backdrop of galactic grandeur. What makes this more astonishing is that every star you see in the night sky is just a neighbour, close by in cosmic terms. The farthest star visible to the naked eye is only a few thousand light-years away. That means the entire canopy of stars that fills your vision is less than a fraction of the galaxy's true size. You're seeing only the tiniest corner, the glowing dust at the edge of the continent. The rest is hidden in darkness, too distant for your eyes to perceive. With telescopes we can trace the arms, map the clusters, glimpse the heart of the Milky Way itself, but even then, we're only scratching at the surface of something far too large to fully grasp. Consider how many stars are in this galaxy. Estimates range from 200 billion to 400 billion. That means there are potentially more planets than there are grains of sand on every beach on Earth. Among them could be worlds with oceans, continents and skies, worlds with life, worlds with civilizations. And yet, even with all those possibilities, the distances are so vast that it is entirely possible no two civilizations will ever meet. Communication, travel, even detection become almost impossible when you are separated by light years. A message sent from one side of the Milky Way to the other would not arrive until 100,000 years had passed. By then, the senders might be gone, their civilization forgotten, their world dust. The galaxy is immense, but it is also isolating. It makes neighbours into strangers, forever separated by an ocean of time and space. Even within this enormity, stars are not evenly spread. They cluster in globular groups, dense spheres of thousands of stars bound tightly by gravity. They scatter in open clusters, loose associations that drift apart over millions of years. They gather into the spiral arms, where gas and dust ignite into new suns, and between them are vast stretches of emptiness, places where you could travel for light years without encountering anything at all. Space is not filled with stars like glitter on black paper. It is mostly void, and the stars are islands in a sea of nothing. The Milky Way is both full and empty, crowded and desolate. From Earth, we see the galaxy as a hazy band stretching across the night sky, a river of light arching overhead. Ancient cultures called it the path of souls, the backbone of the night, the spilled milk of the gods. Today we know it is the combined glow of billions of distant suns. But knowing doesn't make it less awe-inspiring. If anything, it makes it more so. That soft glow is a reminder that we are inside something incomprehensibly vast, that every step we take is happening within a structure so enormous it bends the definition of reality itself. And yet the Milky Way is not unique. It is one of billions of galaxies scattered across the observable universe. Some are smaller, faint smudges barely a fraction of its size. Others are giants, holding trillions of stars and stretching millions of light years across. The Milky Way is not special, it is not central, it is not the largest or the smallest. It is simply one among many, and still, for us, it is everything. Every star you've ever seen, every sunrise, every breath, every thought, all of it has happened inside this one galaxy. We are like insects living on a single branch of a colossal tree, unaware of the forest stretching beyond. If you could step outside the Milky Way and look back, you would see a glowing spiral, its arms curling gracefully around a bright centre. You would see dark lanes of dust cutting through the starlight, nebulae glowing red and pink, clusters of stars like jewels. And then you would see that spiral surrounded by others, scattered across the cosmic landscape like cities across a continent. The Milky Way, immense as it is, would look like just another pinwheel of light, a single city in an endless map of stars. So the next time you look up at the night sky and feel small, remember this. You're not just standing beneath stars, you're inside a galaxy so large it takes light itself 100,000 years to cross. You're part of a structure made of billions of suns, each one potentially holding its own worlds and mysteries. And beyond that, you are part of a universe where the Milky Way is not the exception, but the rule. Our galaxy feels infinite, but it is only a drop in an ocean, and that ocean stretches far beyond anything we can imagine. In the late summer of 1977, humanity launched 2 time machines disguised as spacecraft. They weren't large, they weren't beautiful, and they weren't fast by cosmic standards, but they carried something far greater than machinery. They carried the ambition to step into eternity. We called them Voyager 1 and Voyager 2. Their original task was simple: take a grand tour of the outer planets, send us photographs and data, then keep going until the silence swallowed them. No one expected that almost half a century later, these 2 fragile probes would still be alive, still whispering across the gulf of space. But what makes their story haunting is not just how far they've gone, it's how little they've touched of the universe around them. For all their speed, for all their endurance, their journey shows us just how impossible space truly is. Voyager 2 launched first, in August of 1977, followed by Voyager 1 a few weeks later. Their paths carried them past Jupiter, where they saw storms larger than Earth itself, and Saturn, with its impossible rings stretching like the grooves of a cosmic record. Voyager 2 went further still, giving humanity its only close-up look at Uranus and Neptune, unveiling worlds of icy winds and strange tilted rotations. These flybys changed science forever. Moons we thought were lifeless turned out to have volcanoes, geysers, and oceans hidden beneath ice. Gas giants revealed storms that had raged for centuries. The Voyagers didn't just show us planets, they showed us possibilities. And then, with their missions technically complete, they turned outward and kept flying. Now, decades later, they have crossed into what scientists call interstellar space. That phrase sounds final, like a grand destination, but it is misleading. Interstellar space is not a place, it's a boundary where the solar wind, the charged particles streaming from the sun, can no longer push back the thin gas that fills the galaxy. Passing that boundary means the sun's protection has ended, but it does not mean the journey is anywhere close to finished. Voyager 1 has travelled more than 14 billion miles, yet it is still within a neighbourhood so tiny compared to the galaxy that calling it progress feels like a cruel joke. At its current speed, Voyager 1 moves nearly 40,000 miles every hour. That is fast enough to circle Earth in less than 40 minutes. But even at that incredible velocity, It would need over 40,000 years to reach the nearest star system. 40,000 years. Longer than recorded history, longer than the rise of agriculture, longer than the span of every empire humanity has ever known. If every person alive today had children, and their descendants lived for 100 generations, Voyager would still be gliding silently toward its target. By the time it arrived, humanity might not even exist. Civilizations may rise and collapse dozens of times. Languages will vanish, continents will change shape, and Voyager will still be out there, moving forward, endlessly patient, endlessly alone. This is the crushing reality of cosmic scale. Space is not a crowded ocean of stars waiting just beyond the next wave. It is emptiness. Vast, unrelenting emptiness. Stars are separated by distances so extreme that even light, the fastest thing in existence, takes years to travel between them. Imagine sending a message and knowing it won't arrive until your descendants are long dead. Imagine traveling with every ounce of technology you can imagine and realizing you will never live to see another sun. That is the prison of space. And Voyager, for all its glory, is trapped in it too. But the beauty of Voyager lies not in its destination, but in what it carries. Each probe was given a golden record, a kind of time capsule etched with sounds and images from Earth. On it are greetings in 55 languages, from Akkadian to Wu. There are the sounds of birds, waves, and thunder. There is music, Bach and Beethoven, but also jazz and rock and roll. And hidden within those grooves is laughter, the simple, unremarkable sound of a human being caught in joy. It is unlikely anyone will ever hear it. The odds of another civilization stumbling across Voyager are so close to zero they might as well not exist. Yet we sent it anyway. Why? Because Voyager is not about being heard. It is about refusing to stay silent. It is about declaring to no one in particular that we existed, that we thought, that we dreamed. As it travels, Voyager continues to send faint signals back to Earth. Each transmission takes more than 20 hours to arrive, carried by a transmitter weaker than a car headlight. Across billions of miles, that signal fades, stretched thin until only the most sensitive radio dishes on Earth can catch its whisper. Soon, even that will end. The probes are powered by radioactive decay, and their energy is fading. Instrument by instrument, NASA has shut down their systems to conserve power. One day, not far in the future, the last signal will arrive. The probes will fall silent, and then, for all practical purposes, Voyager will be gone. No more data, no more whispers, just two silent machines drifting endlessly through the dark. But silence does not mean death. Voyager will endure as long as physics allows. The golden records will last for billions of years, protected by the vacuum of space. Long after Earth is gone, long after the sun has burned out and swallowed the inner planets, the Voyagers will still be out there. They will carry our voices, our music, our laughter through eternity. They may never be found, but they will always exist. Proof that for a fleeting moment in cosmic history, we dared to reach beyond ourselves. And maybe that is the point. Voyager's journey is not futile. It is the purest expression of what it means to be human. We explore not because we expect success, but because we refuse to accept stillness. We send our machines into the void knowing they may never return, knowing they may never be heard, but believing that the act itself matters. Voyager is not a failure because it will not arrive. Voyager is a triumph because it is moving at all. Because it carries our story forward into a universe that is not built to care about us. Because it says in its own silent way that we were here and we reached out. So when you think of Voyager, don't think of it as a ship lost in the dark. Think of it as a symbol, a fragile testament to human curiosity, gliding endlessly into the unknown. It will not reach another star in your lifetime, or your children's, or your children's children's. But that does not matter. What matters is that it goes, that it continues, that in the face of distances so vast they crush our imagination, Voyager still sails forward. And in that forward motion lies the most human truth of all. We are small, yes, but we are relentless. The Milky Way. We use the name casually, almost gently, as though it's a familiar neighbourhood, something we can picture by glancing up at the faint band of light that crosses the night sky. But the reality of the Milky Way is so staggering, so beyond human comprehension, that even the numbers sound like nonsense when you try to wrap your head around them. You live inside a galaxy that is over 100,000 light-years across. That means if you could somehow ride on a beam of light, the fastest thing in existence, it would still take you 100,000 years to travel from one edge to the other, and you wouldn't even be halfway across the universe. You wouldn't even leave the city limits of cosmic reality. You'd just be crossing your own neighborhood. Think about what a light year actually means. It's not time, it's distance. A single light year is almost 6 trillion miles. Multiply that by 100,000, and you're staring into a number so large the human brain simply cannot visualize it. We are wired to understand miles, maybe thousands of miles, the kind of distances you might fly in an airplane, but trillions upon trillions of miles. That is not something your mind evolved to handle. The Milky Way exists on a scale we can't feel, can't see, can't even pretend to measure with normal perspective. It is simply too vast, and yet this impossible expanse is filled with life. Not life as in biology, but life as in movement, energy, creation. It is home to hundreds of billions of stars. Some estimates suggest 400 billion. Imagine standing on a beach scooping up a handful of sand and realizing that even in that handful, you are holding more grains than there are stars visible to the naked eye from Earth. Now stretch that thought further. Every grain of sand on every beach, every desert, every riverbank multiplied together, that's still not enough to match the number of planets that likely exist in the Milky Way alone. This is not a galaxy of emptiness, it is a galaxy of abundance. Stars are born in clouds of gas so vast they make our entire solar system look like a speck. They live out their lifespans, burning bright for billions of years, and then die in explosions so violent they can outshine the galaxy itself. The Milky Way is not static. It is a living system, constantly creating and destroying, like a city that never sleeps. At the heart of this sprawling city lies something even more unsettling. A supermassive black hole called Sagittarius A. It contains the mass of more than 4 million suns. Imagine compressing millions of stars into a single point where gravity is so strong not even light can escape. That's the center of your galaxy. Around it, stars whirl in orbits at thousands of miles per second, entire clusters being flung about like sparks in a bonfire. The sheer violence at the core of the Milky Way is something we rarely think about. Yet it governs the entire structure of the galaxy. It is the anchor, the unseen force keeping the spiral arms in place. And your sun, your comfortable, warm, ordinary sun, is just one of hundreds of billions circling around it, like a moth orbiting a fire too far away to burn but too powerful to escape. Our solar system sits in a small spiral arm known as the Orion Arm, roughly halfway out from the center of the galaxy. If the Milky Way were a giant disk, our sun would be a dot not even noticeable on the edge of one of its swirling arms. That's where everything you've ever known exists, on a minor branch of a spiral, orbiting the center at about 500,000 miles per hour. It will take the sun 230 million years to make a single orbit around Sagittarius A. That means the last time our solar system was in its current position in the galaxy, dinosaurs had just begun to walk the Earth. By the time we complete another lap, humanity may not even exist, or it may have evolved into something unrecognizable. That is the timescale of our galaxy. It doesn't measure time in centuries or even millennia. It measures it in galactic years, and we are barely halfway through our first. From Earth, the Milky Way looks like a soft band of light arcing across the night sky. To ancient cultures, it was the path of souls, a celestial river, the backbone of the heavens. But what you're seeing when you look at that faint glow is the combined light of billions of distant stars. Your eyes can't separate them, so they blur into a shimmering haze. That band is just the edge of our galaxy, the place where your line of sight stretches deep into the crowded disk of stars. With a telescope, the blur resolves into pinpoints, each one a sun, each one possibly surrounded by planets. But even then, you're only scratching at the surface. You're seeing a thin cross-section of a disk that extends 100,000 light-years in all directions. Most of it is invisible to you, forever hidden by distance and dust. The Milky Way is not uniform. It is made of spiral arms rich with star formation, dark lanes of gas and dust that blot out the light, and clusters where stars gather like families. Some of these clusters are so dense that if you lived on a planet inside one, your night sky would be ablaze with hundreds of bright stars, each one rivaling our moon in brilliance. Others are so empty that if you lived there, you might never see another star at all. Space is not evenly distributed. It is both overcrowded and desolate depending on where you stand. The Milky Way holds both extremes within its arms, and here is the most humbling truth. For all its size, the Milky Way is not unique. It is just one galaxy among billions. Through our telescopes, we see galaxies stretching across the observable universe, each one a swirling city of stars, each one as vast or vaster than our own. The Andromeda Galaxy, our nearest large neighbour, is even bigger than the Milky Way, containing 1 trillion stars, and in 4 billion years the Milky Way and Andromeda will collide, merging into a new, even larger galaxy. Stars will be flung into new orbits, gas clouds will ignite into bursts of star formation, and the structure of our galaxy will be remade. Even galaxies are temporary. Even they are just pieces in a larger ongoing story. So when you think of the Milky Way, don't imagine it as just the streak of light above your head. Imagine it as a colossal disk of stars, so vast that light itself struggles to cross it, so crowded that billions of suns burn within it, and yet so ordinary that it is just one among billions more. You live on a planet circling a small star, in a minor arm, halfway out from the centre. Everything you are, everything you've ever known is a footnote in a structure so vast it makes human history look like the blink of an eye. The Milky Way is not just your home. It is your reminder that home itself is small, that even when you scale up from Earth to the galaxy, you're still standing on the edge of infinity. When you step outside on a clear night and look up, you see stars scattered across the sky. If you're far enough from the city lights, you might even see the Milky Way itself, that glowing ribbon of light stretching overhead. And for most of human history, people believed that was the whole universe. The stars, the glowing band, the dark between them, that was everything. But what modern astronomy has revealed is something far more unsettling, far more staggering. The Milky Way is not everything. It's not the universe. It's not even rare. It is one of billions of galaxies, each one its own colossal system of stars, gas and dust. And some of them, unbelievably, are close enough to see with your naked eye, even if you don't realize it. Our nearest large neighbour is the Andromeda Galaxy, also known as M31. From Earth, it looks like a faint smudge of light in the constellation Andromeda, barely noticeable unless you're under very dark skies. But that smudge is a galaxy more than 2.5 million light-years away. Think about that. The light entering your eyes tonight from Andromeda left that galaxy before humans even existed as a species. Back then, Earth was home to early ancestors struggling to survive, and yet that light has been travelling uninterrupted ever since, crossing a gulf of 25 quintillion miles just to arrive in this single moment. And Andromeda itself is enormous, larger than the Milky Way, with perhaps 1 trillion stars. When you see that faint smudge, you're not seeing a star, not a cluster, not a nebula. You're seeing an entire galaxy, another city of stars across an ocean of void. Andromeda is not alone. Our Milky Way belongs to what astronomers call the local group, a small cluster of about 50 galaxies bound together by gravity. The Milky Way, Andromeda, and a smaller galaxy called Triangulum are the 3 largest members. Surrounding them are dozens of dwarf galaxies, tiny companions orbiting the giants. Some of these dwarfs are so faint they were only discovered in the last few decades. They are fragile star-poor systems, often little more than smudges of ancient stars slowly being torn apart by their larger neighbours. When you zoom out, the local group looks like an archipelago, scattered islands of light floating in a sea of emptiness, bound together in an invisible gravitational dance, and that dance has a dramatic future. In about 4 billion years, Andromeda and the Milky Way will collide. Imagine 2 galaxies, each containing hundreds of billions of stars, rushing toward each other at 250,000 miles per hour. When they meet, they won't crash like solid objects. Instead, they'll pass through each other, their stars rarely colliding but their gravity tearing each system apart. Spiral arms will distort, gas clouds will compress, and new bursts of star formation will ignite. Over the course of billions of years, the 2 galaxies will merge into one, forming a new elliptical giant. Earth, if it still exists by then, will orbit a sky filled with chaos. Multiple suns brighter than any we've ever known, nebulae glowing across the heavens, galaxies colliding in slow motion. The night sky will become unrecognizable, transformed into a theatre of cosmic violence and beauty. Andromeda may be the most famous neighbour, but it's not the only one. Surrounding our galaxy are small companions like the Large and Small Magellanic Clouds, visible in the southern hemisphere. These are irregular dwarf galaxies, clumps of stars and gas being slowly pulled apart by the Milky Way's gravity. Streams of their material stretch across the sky, forming rivers of stars that one day will be fully absorbed. In a way, the Milky Way is already feeding on its smaller companions, consuming them piece by piece, like a predator in a cosmic ecosystem. The local group is not a peaceful family of galaxies. It is a battlefield where gravity decides who survives and who is devoured. And beyond the local group lies the Virgo supercluster, a vast collection of galaxy clusters bound together on even larger scales. The local group itself is just one small corner of this structure, like a tiny village on the edge of a sprawling empire. The Virgo cluster, at the heart of the supercluster, contains thousands of galaxies, and beyond Virgo, astronomers have discovered that even superclusters are not isolated. They form filaments, colossal strands of galaxies stretching across hundreds of millions of light-years. Together, these filaments create what scientists call the cosmic web, the largest structure in the universe. In this web, galaxies are not evenly spread, but instead form nodes and threads, like dewdrops caught in a spider's web of unimaginable size. Our Milky Way, our local group, our Virgo supercluster, they're all just threads in this cosmic tapestry. Think of the scale here. When you look at Andromeda through a telescope, you're seeing a galaxy 2.5 million light-years away. But the Virgo cluster is over 50 million light-years away. That means the light we see from those galaxies left when dinosaurs still ruled the Earth. And even that isn't far compared to the full observable universe. There are galaxies so distant their light has been travelling for over 13 billion years, nearly as old as the universe itself. When we look at them, we are looking into the past, seeing them as they were when the cosmos was young. The night sky is not just a map of space, it is a time machine, showing us billions of years of history frozen in light. The idea that our galaxy is just one of many was once unthinkable. 100 years ago, astronomers debated whether the Milky Way was the entire universe. The Great Debate of 1920 pitted two scientists against each other, one arguing that the Milky Way contained everything, the other suggesting that the fuzzy spiral nebulae seen through telescopes were actually entire galaxies far away. It wasn't until Edwin Hubble, using the Hooker telescope at Mount Wilson, measured the distance to the Andromeda galaxy that the truth was revealed. The Milky Way was not the universe. It was just one island in a vast sea. That discovery transformed our place in the cosmos. Overnight, the universe became thousands of times larger than we had imagined, and since then, with better telescopes, we've learned it is larger still. Billions of galaxies, each one filled with billions of stars. The scale is so enormous that even today it's hard to accept as reality. So the next time you step outside and look up, remember this. When you see that faint smudge of Andromeda, you're looking at another galaxy filled with 1 trillion stars. When you notice the hazy glow of the Milky Way, you're looking along the edge of our own spiral. And beyond those, though invisible to your eyes, are billions more, scattered like islands in an endless dark ocean. Our local group is just a cluster of galaxies bound together, and beyond it lie clusters of clusters, weaving into a cosmic web so vast that even the speed of light struggles to describe it. You live not just in a solar system, not just in a galaxy, but in a universe of galaxies, each one a universe of its own. When people talk about the universe, they often imagine it as endless, stretching forever in every direction. But the truth is stranger. The universe has a limit, not a wall, not a physical edge you could ever touch, but a horizon beyond which we cannot see. We call it the observable universe, and its boundary is not determined by space, but by time. Light moves fast, 186,000 miles per second, but it does not move infinitely fast. It takes time to travel. That means when we look into space, we're also looking into the past. A star 100 light-years away is seen as it was 100 years ago. A galaxy a billion light years away is seen as it was a billion years ago. And if you keep looking farther, eventually you reach the ultimate limit, the moment the first light was freed, nearly 13.8 billion years ago. That light, stretched thin by the expansion of the cosmos, still washes over us today, a faint glow known as the cosmic microwave background. It is the oldest picture of the universe, a baby photo of creation itself. Beyond that, darkness. Not because nothing exists, but because the light from beyond has not had enough time to reach us. The observable universe forms a sphere centered on Earth, but not because we are special. Every point in the universe has its own observable sphere. Ours just happens to be 93 billion light-years across. That number might seem impossible. How can the universe be 13.8 billion years old, but 93 billion light-years wide? The answer lies in expansion. Since the Big Bang, space itself has been stretching. Galaxies are not moving through space so much as space itself is carrying them apart, like raisins baked into a loaf of bread. The more the bread expands, the farther apart the raisins become. So while the light we see began its journey billions of years ago, the galaxies that emitted it are now much farther away than they were when that light set out. The edge of the observable universe is not the edge of everything, it is simply the farthest we can ever see. Beyond that horizon lies more universe, perhaps infinitely more, hidden forever beyond our reach. Think about the scale of this boundary. 93 billion light-years across, hundreds of billions of galaxies, trillions upon trillions of stars. And yet, that is only the part we can observe. If the universe is infinite, then what we see is just a drop in an endless ocean. If the universe is finite but larger than our horizon, then we are like sailors on a small raft staring across the fog, knowing more land must exist but unable to ever set foot on it. Either way, the reality is humbling. We are locked inside a cosmic bubble defined not by walls but by time itself. The universe hides most of itself from us, and no amount of technology can ever break that barrier. We are prisoners of light speed, and the prison is unbreakable. Yet even within this observable sphere, the universe is astonishing. We see galaxies so far away their light left when the universe was young, less than a billion years old. They look small, clumpy, chaotic, because they were. Galaxies then had not yet settled into the graceful spirals we see nearby. They were still forming, colliding, tearing themselves apart. When we peer at them, we are witnessing creation in progress. We are looking not just at distance but at time travel, catching glimpses of a universe that no longer exists. Those galaxies may now be massive, ordered structures, or they may no longer exist at all, torn apart by mergers or consumed by black holes. The light we see is only a frozen memory, an echo of what was. The cosmic microwave background, that faint afterglow of the Big Bang, marks the ultimate limit. Before 380,000 years after the Big Bang, the universe was a seething plasma opaque to light. Photons could not travel freely. Only after it cooled did light break free, filling space in all directions. That is what we see today. A faint, uniform glow spread across the entire sky. To the naked eye, it is invisible. But to radio telescopes, it is everywhere, whispering the story of the universe's birth. That glow tells us the cosmos began as something hot, dense and uniform, and that it has been expanding and cooling ever since. Every time you tune an old TV and see static, a tiny fraction of that fuzz is the ancient light of creation, still arriving after nearly 14 billion years. You're literally seeing the echo of the universe's first moments. And yet, as far as we can see, the universe has no center, no edge. From any point the view looks the same, galaxies rushing away in every direction, expansion unending. That means the observable universe is personal, relative. From Earth, it looks like we are at the center. From a distant galaxy, they would see themselves at the center of their own sphere. There is no single viewpoint, no privileged place. Every observer is surrounded by their own horizon, each one a cosmic bubble of visibility. Beyond all of them lies more universe, unreachable, unknowable. This raises unsettling questions. If the observable universe is all we can see, how can we ever know what lies beyond it? Could there be regions where the laws of physics are different? Could there be other pockets of space with galaxies arranged in ways we cannot imagine? Or could there be nothing, a void where even space and time break down. We may never know. The boundary of the observable universe is absolute. It is not a line we can cross. It is the limit written into the fabric of reality itself. But maybe the most humbling thought is this: everything you know, everything that has ever happened, every planet, every star, every galaxy we've ever observed, all of it fits inside this sphere. 93 billion light-years across sounds vast, but compared to infinity, it is nothing. It is a grain of sand, a droplet in an endless sea, and yet it contains everything you have ever loved, feared, or imagined. The observable universe is not just a boundary of sight. It is a boundary of existence, at least for us. Beyond it lies the unknown, perhaps the unknowable, forever teasing us with questions we cannot answer. So when you look up at the night sky, you're not just seeing stars. You're looking through time. You're gazing across billions of years of history, watching ancient light arrive at last, and you are staring at the edge of everything humanity will ever be able to witness. The observable universe is our cage, our theatre, our window. It shows us enough to overwhelm us, but never enough to satisfy us. It is vast enough to make us feel small, yet limited enough to remind us how little we truly know. The universe does not end at that edge. Only our sight does. Beyond it lies infinity, or something stranger still. And perhaps the greatest truth is that no matter how far we look, no matter how deep we peer into the darkness, there will always be more beyond, waiting in silence, forever hidden. If you look out at the universe, everything you see, stars, planets, nebulae, galaxies, all of it feels like the totality of existence. Brilliant suns burning in the darkness, worlds spinning through the void, gas clouds glowing in hues of pink and blue. But here's the twist. Everything visible, everything that shines, is only a fraction of reality. In fact, it is the smallest fraction. All the galaxies, stars, and planets combined make up less than 5% of the universe. The rest is invisible, untouchable, and almost entirely unknown. We call one part of this invisible majority dark matter, and though we cannot see it, though we cannot touch it, we know it is there because without it, the universe itself would not hold together. The story begins with galaxies. When astronomers measured how fast stars orbit the centre of their galaxies, they expected to find the outer stars moving slower, just as planets farther from the sun orbit more slowly. That's how gravity should work. Distance should reduce the pull, but what they found was shocking. Stars on the outer edges were orbiting just as fast as those near the centre. By the laws of physics, those stars should have flown off into space, flung outward like rocks from a slingshot, but they didn't. They held together, bound by something invisible. The only explanation was that there must be more mass than what we can see, something hidden, exerting gravity but giving off no light. That unseen mass was named dark matter. Today, we estimate that dark matter makes up about 27% of the universe. That means there is 5 times more dark matter than normal matter. The chair you're sitting on, the food you eat, your body itself, all of that belongs to normal matter, the kind that interacts with light. But most of the cosmos is made of matter that doesn't shine, doesn't glow, doesn't reflect. It's there, but it's invisible, like a ghost haunting every galaxy, and its presence is not subtle. Without dark matter, galaxies would fly apart, galaxy clusters would not exist, and the cosmic web, the vast structure of filaments connecting the universe, would never have formed. Dark matter is the scaffolding of the universe, the hidden skeleton that holds everything in place. But what is it? That's the mystery. We don't know. It's not atoms, not the particles that make up stars and planets. It doesn't emit radiation, doesn't absorb light, doesn't interact with electromagnetism at all. The leading theories suggest it is made of exotic particles we haven't discovered yet. Names like WIMPs, weakly interacting massive particles, or axions, particles so elusive they slip through matter unnoticed. Imagine 1 billion of them streaming through your body every second without leaving a trace. If dark matter is real, and all the evidence suggests it is, then you are immersed in it constantly. Your entire life unfolds inside an invisible ocean of particles that neither you nor your senses can detect. To prove its existence, scientists have built elaborate experiments deep underground, shielded from cosmic rays, searching for the faintest whisper of dark matter interacting with ordinary matter. Detectors filled with liquid xenon, sensors cooled to near absolute zero, all waiting for a rare collision that would reveal its nature. So far, nothing. Dark matter remains silent, a puzzle that refuses to yield its secret. And yet, we see its fingerprints everywhere. When we map galaxies, when we measure how clusters bend light through gravity, when we simulate the formation of the cosmos, dark matter is the missing piece that makes the equations work. Without it, the entire universe falls apart. Consider gravitational lensing. According to Einstein's theory of relativity, massive objects bend the fabric of space-time, curving the path of light. When astronomers looked at galaxy clusters, they saw light bending far more than the visible mass could explain. It was as though something heavy, something invisible, was distorting space itself. Dark matter was the culprit, bending light without ever being seen. It is everywhere, woven into the structure of the cosmos like invisible threads. Without it, galaxies would unravel. With it, the universe holds together like a tightly laced web. The unsettling part is that dark matter may never reveal itself to us directly. It doesn't shine, doesn't reflect, doesn't touch. We may only ever see its effects, like the wind bending trees without ever glimpsing the wind itself. That makes it one of the greatest mysteries of modern science. We live in a universe where most of the matter is invisible, and we don't know what it is. We exist in ignorance, surrounded by something that defines everything, yet remains hidden. But dark matter is only half the story. If it accounts for about 27% of the universe, and normal matter makes up less than 5%, that leaves nearly 70% unaccounted for. That 70% is something even stranger, something called dark energy. Unlike dark matter, which binds the universe together, dark energy is tearing it apart. Observations of distant galaxies revealed that the expansion of the universe is accelerating. Galaxies aren't just moving away, they're moving away faster and faster, as though pushed by a mysterious force. That force is dark energy. It dominates the universe. Yet we know even less about it than dark matter. It is the ultimate unknown, the invisible hand shaping the fate of everything. So here's the humbling truth. The universe we see, the stars, galaxies, nebulae, and planets, are the exception, not the rule. They are the scraps, the leftovers, the tiny fraction of reality that happens to glow. The rest is hidden, a cosmos made of darkness. We are like creatures living in a cave, mistaking the faint flicker of firelight for the whole world, while the vast unseen stretches beyond our reach. Everything you've ever known, every discovery ever made, every telescope ever pointed skyward, has only touched 5% of reality. 95% remains invisible, waiting in silence. And yet, perhaps that is the most human part of this story. We don't accept the darkness. We reach into it, question it, demand to know what it hides. We build machines to listen for whispers, satellites to map the invisible, theories to explain the impossible. Dark matter may elude us forever, but the pursuit itself defines us. To wonder about the invisible is to admit that we are small but curious, fragile but relentless. And maybe that curiosity is what matters most. Because even if we never grasp the true nature of dark matter or dark energy, we will never stop asking. So the next time you look up at the night sky and see the stars, remember this. They are only the tip of the iceberg. Behind them, beneath them, all around them lies a universe of shadow, unseen but undeniable. Dark matter holds the galaxies together. Dark energy drives them apart. Between the two, the fate of the cosmos is written, and you, living on a tiny planet circling an ordinary star, are caught in the middle of a battle between forces you cannot see. Forces that will decide how the universe ends. Will it expand forever, cold and dark? Will it collapse in on itself, a final reversal of creation? Or will something stranger happen, beyond our ability to imagine? We don't know. But one truth is certain. The visible universe is not the real universe. What we see is only the surface. The true cosmos hides in the dark. The universe has a beginning, and that means it must also have an end. For most of human history, we imagine creation as eternal, the heavens fixed and unchanging, stars burning forever in an endless night. but science tells us otherwise. Stars are born, they live, and they die. Galaxies collide and merge. The cosmos itself evolves, expands and cools. And if we look far enough into the future, if we push the clock forward not thousands or millions but trillions of years, we can glimpse the final fate of everything. It is not fire. It is not chaos. It is silence. The universe, if our current understanding is correct, is headed for something called heat death. The slow, inevitable decay into nothingness. To understand why, you have to start with energy. The second law of thermodynamics states that entropy always increases. Entropy is a measure of disorder, of energy spread evenly across a system. Once energy is evenly distributed, once no gradients remain, nothing more can happen. No work can be done. Imagine a room with hot and cold regions. Heat flows, movement occurs, systems evolve. But once the room is the same temperature everywhere, once equilibrium is reached, it becomes still. The universe is the same. Right now, energy flows. Stars burn, galaxies form, black holes feed, but this is temporary. Energy is being spread thinner and thinner as the universe expands. Eventually, there will be no gradients left, no difference between one place and another, no motion, no change, just an endless, featureless dark. The first step toward that fate is the death of stars. Our sun, like all stars, is finite. It will burn for billions of years, then swell into a red giant, casting off its outer layers before collapsing into a white dwarf. Other stars will follow their own paths, some exploding in brilliant supernovae, some quietly fading into black dwarfs, some collapsing into neutron stars or black holes. Over time, star formation itself will slow. The raw materials, gas and dust, will be used up, locked into dead stars and stellar remnants. The glittering cosmos we see today, filled with billions of suns, will gradually dim as fewer new stars ignite. Eventually the age of stars will end. But the universe does not stop there. Trillions of years into the future, even the white dwarfs will cool into black dwarfs, dark, frozen cinders drifting silently in space. Neutron stars will fade, their heat radiating away. Black holes will dominate, swallowing what remains. For a time, the universe will be a graveyard of collapsed objects, a landscape of invisible giants scattered across an otherwise dark void, and then even the black holes will begin to die. According to Stephen Hawking, black holes are not truly eternal. They radiate energy, a process called Hawking radiation, slowly evaporating over unimaginable spans of time. The larger the black hole, the slower it evaporates, but even the most massive will eventually vanish. Imagine waiting 10 to the power of 100 years, a number so vast it dwarfs all human history, all stellar lifespans. In that unimaginable future, black holes themselves will shrink and wink out of existence, leaving nothing but a thin haze of radiation. What comes after is the era of heat death. With no stars, no black holes, no structures left, the universe will be filled only with particles, photons, and fading radiation spread evenly across infinite space. Temperature will approach absolute zero. Time will still exist, but nothing will happen. No gradients, no energy differences, no processes, just silence and darkness stretching forever. It is not an end with drama. There is no great collapse, no fire consuming everything. It is worse. It is the slow fading of all possibility, the eternal stillness of a cosmos that once burned with light, but now remembers nothing of itself. This vision of the end is almost unbearable to contemplate. It strips away meaning, purpose, drama. The universe does not end in a grand finale, but in a whisper, an infinite nothing where not even memory survives. And yet, there is something profoundly human about our ability to imagine it. We live for only decades, our civilizations for only centuries, our species for only a blink compared to cosmic time. And still, with fragile minds on a tiny planet, we look trillions of years ahead and picture the death of everything. That act alone is defiance. Of course, heat death is only one possible ending. The expansion of the universe driven by dark energy may accelerate forever, tearing galaxies away until each one is isolated, marooned in its own bubble of darkness. Or perhaps dark energy is not constant. Perhaps it will reverse, pulling everything back into a catastrophic collapse known as the Big Crunch. In that vision, the universe ends as it began, in fire and density, a mirror of the Big Bang. Some theories even suggest cycles, an endless series of births and deaths, expansions and collapses, a universe reborn from its own ashes. But with the evidence we have today, heat death remains the most likely fate, a universe expanding forever, growing colder and emptier until nothing remains. And that raises a haunting question. What does it mean for us? Humanity will be gone long before any of this happens, of course. Even our sun's death is billions of years away, far beyond our horizon. But the idea that the cosmos itself is finite, that all light will one day vanish, forces us to confront our own smallness. It reminds us that meaning cannot be found in permanence, because nothing is permanent. Not stars, not galaxies, not even the universe itself. Meaning must come from the present, from the fleeting spark of life that exists in the middle of this vast temporary blaze. So when you look up at the night sky, remember this. You are seeing fire in its youth. You are witnessing the universe while it still burns, while stars still live, while galaxies still shine. You are alive at a privileged moment, when the cosmos is vibrant, when light still floods the void. Trillions of years from now, there will be no skies, no suns, no watchers left to marvel at creation. You exist in the golden age of the universe, the brief span when it is filled with beauty. That beauty is temporary, but so are we. And maybe that is what makes it matter. The universe will end not in fire, but in silence. But until that silence comes, it roars with stars, it hums with galaxies, it teems with light and life. And for a brief moment in that roar, for a blink in the vastness of time, we are here to see it. That, more than anything, is what makes this story worth telling. When we reach the edge of what science can currently explain, the questions don't end, they multiply. We've seen the observable universe, we've mapped galaxies billions of light years away, and we've peered back almost to the beginning of time. But beyond that, beyond the horizon of light, beyond the edges of our equations, that is where speculation takes over. That is where we begin to ask not just what is, but what might be. And one of the boldest ideas of all is that our universe, the totality of everything we can see, touch, and measure, might not be the only one. It might be just one bubble in a vast sea of universes, a multiverse where the cosmos we know is nothing more than a drop of water in an infinite ocean. The idea of the multiverse arises from physics itself. The Big Bang did not create a simple explosion of matter into empty space. It created space and time themselves, expanding in every direction. But some theories suggest the process of inflation, the rapid expansion in the earliest fractions of a second, might not have ended everywhere at once. Instead, inflation could continue in pockets, creating new universes beyond our own, each sealed off, each with its own space, time, and possibly even its own laws of physics. In this view, our universe is just one bubble in a vast foam of reality, forever separated from its neighbours, forever unaware of what lies beyond. And if that's true, then everything we see, the galaxies, stars, even ourselves, is only a fragment of a much larger, stranger creation. Imagine this. In one universe, gravity might be stronger, stars might burn out in millions instead of billions of years, and life as we know it could never form. In another, particles might combine differently, creating bizarre matter and alien chemistry. In still another, conditions could mirror our own so closely that there might be another Earth, another you, living out a life eerily similar yet never touching ours. The multiverse is not just speculation, it is a stage for infinite possibilities, each one playing out its own version of reality, hidden forever beyond our reach. And yet, hints of something beyond our universe might already be whispering to us. The cosmic microwave background, the faint afterglow of the Big Bang, is not perfectly smooth. It has tiny fluctuations, fingerprints of the universe's birth. Some scientists have wondered whether strange anomalies in that background could be the scars of collisions between our universe and others, evidence that our cosmic bubble once brushed against another. These ideas remain controversial, unproven, but they remind us of how little we know. The horizon of the observable universe may not be the horizon of reality itself. It may be just the edge of the map, beyond which lies a wilderness we cannot explore. Other speculations go even deeper. Some physicists propose that the universe itself is not the fundamental reality but an emergent one, a hologram projected from information stored on its boundaries. In this picture, everything you see, matter, energy, space, time, is the shadow of a deeper reality made of pure information. Others suggest that quantum mechanics, with its strange rule that particles can exist in many states until observed, might hint at branching realities. Every decision, every outcome might create a split, a new universe unfolding with each possibility. In one, you turned left. In another, you turned right. In one, Earth thrived. In another, it perished. If this interpretation is true, the multiverse is not just vast in space, but infinite in branching timelines. Even the laws of physics themselves may not be universal. What we call constants, the strength of gravity, the speed of light, the charge of the electron, may be local settings, tuned differently in other universes. If so, the fact that we exist at all is not an accident but a necessity. Out of countless possible universes, only a few would allow stars to shine, planets to form, and life to evolve. This idea, called the anthropic principle, suggests that we observe this universe not because it is special, but because only universes like this one can contain observers at all. We live here because here is the only kind of place where living is possible. But perhaps the most unsettling speculation is that reality itself may not be fundamental. Some scientists and philosophers have even entertained the possibility that the universe is a simulation, a vast construct running on some unimaginable computer, built by beings outside our reality. In this view, every particle, every star, every galaxy is nothing more than code, rules being followed in perfect precision. And if that is true, then the multiverse might simply be a library of simulations, each with its own parameters, each spinning out its own story. Of course, there is no proof of this, but the fact that our equations can even describe the idea is a reminder of how fragile the boundary between science and philosophy becomes when we reach the limits of knowledge. What lies beyond the observable universe? Perhaps infinite galaxies stretching into eternity. Perhaps other universes, each stranger than the last. Perhaps layers of reality we cannot begin to imagine. The one certainty is that our view is limited. We are creatures of light, bound to see only what light can deliver, and light itself has a speed. That means there will always be more beyond, hidden in darkness. No telescope, no experiment, no voyage will ever reveal the totality of existence. The edge of what we can know is not the edge of reality. It is simply the edge of us. But maybe that is not a reason for despair. Maybe it is what makes the story of the universe beautiful. If everything were knowable, if every secret could be uncovered, the cosmos would be smaller, tamer, less mysterious. Instead, we live in a universe that forever outruns our understanding, that hides more than it reveals, that teases us with glimpses of a truth always just beyond reach. That mystery is not a flaw. It is the very thing that gives us purpose. It drives us to build telescopes, to write equations, to dream of what might be. So when you think about the multiverse, don't picture it as a sterile set of equations or a distant abstraction. Picture it as an endless horizon, a sea without shore, filled with possibilities we cannot see but can imagine. Picture galaxies blooming like sparks in every direction, not just across our sky but across realities. Picture other worlds, other laws, other versions of yourself, all existing side by side in silence. Whether the multiverse is real or not, the act of considering it expands the mind, stretching our imagination to scales as vast as the cosmos itself. And in the end, maybe that is the point. Whether there is one universe or infinite, whether reality is fundamental or simulated, whether our cosmos ends in fire, collapse, or silence, the human spirit remains the same. We are tiny, fragile creatures on a pale blue dot, yet we dare to imagine infinity. We dare to ask what lies beyond. We dare to believe that the story is bigger than we can ever see. And maybe, just maybe, the act of asking makes us infinite too. After travelling through the unimaginable distances of space, after peering into galaxies, dark matter, and the fate of the universe itself, it's easy to feel small, almost too small. The human mind struggles to hold on to meaning when stacked against such immensity. What does one life matter in a universe of trillions of galaxies? What does one planet matter when it's barely a speck in a single spiral arm of a single galaxy? These questions press on us when we look at the stars. They can feel crushing, as though scale itself strips away significance. And yet the opposite might be true. Understanding the scale of the universe doesn't erase meaning, it creates it. It shows us how precious, how extraordinary, how fragile and rare it is that we're here at all. Think about Earth, this tiny blue dot floating in the void. On cosmic scales, it is less than nothing. If the Milky Way were the size of the United States, Earth would be a dust mote smaller than a single grain of sand. And yet, it is here that oceans roll, forests grow, minds wonder, and hearts feel. In all the vastness we have explored, all the billions of stars we've catalogued, Earth is still the only place we know with life. That makes it unique. That makes it sacred. Scale does not erase its value. It multiplies it. Because the smaller we are compared to the universe, the rarer our existence becomes. Out of all the galaxies, all the stars, all the empty voids, here is one world where life took root and asked the question, why? And that question is not trivial. In the face of infinite darkness, we look up and demand to understand. We invent stories, we write equations, we send probes into the night. That is not the behavior of something meaningless. That is the mark of beings who know their fragility and still refuse to be silent. Every scientific discovery, every artistic creation, every act of kindness, every moment of connection between two human beings, it all takes place against a backdrop so large it makes the very act of existing feel defiant. The universe does not care about us, but that does not mean we do not matter. Meaning is not given from the outside, it is created from within. This is why scale matters, not because it diminishes us, but because it forces us to see ourselves in perspective. Nations rise and fall, wars burn, economies grow and collapse. On a galactic scale, these events are less than dust storms on a single afternoon, and yet to us, they mean everything. They shape our lives, our hopes, our fears. Understanding cosmic scale should not lead us to nihilism, but to humility. It reminds us that our conflicts are small, that our divisions are trivial, that our survival is fragile. It reminds us that Earth is not a battlefield for endless fights, but a lifeboat in an endless sea, a lifeboat we cannot afford to destroy. When Carl Sagan described Earth as a pale blue dot, he wasn't stripping it of value, he was giving it more. He was showing that in the immensity of the cosmos, the only place where human love and struggle exist is here. All our art, all our history, all our dreams, they happen on this pinprick of light. That should make us protective, not despairing. That should make us treasure every moment, every connection, every fragile ecosystem that sustains us. Scale is not an enemy of meaning. It is a lens that sharpens it. It also frees us. Too often we see ourselves as the center of everything, our problems as absolute, our fears as final. But when you understand cosmic scale, you see that your mistakes are not eternal. Your failures are not galaxies. Your heartbreak is not written into the stars. You're small, yes, but that smallness is liberating. It means you can choose, you can change, you can create meaning in a universe that demands none. Your story matters because you choose for it to matter. The universe is vast enough to be indifferent, but it is also vast enough to allow infinite possibility. And there is wonder in that possibility. The night sky is not just a ceiling of stars, it is a window into scale itself. When you look up, you are seeing across time and distance, glimpsing light that began its journey before humans even existed. That perspective should not crush you. It should ignite you, because it means you are part of something bigger, something ancient, something ongoing. You are not outside the universe staring at it from a distance. You are inside it, made of the same atoms that burn in stars, the same carbon forged in supernovae, the same hydrogen born in the Big Bang. Scale reminds you that you belong here, that your very body is a record of cosmic history. And yet, despite this, most of us rarely look up. We live in cities where the stars are drowned by artificial light, where the sky is no longer a storybook but a blank ceiling. We forget the scale above us. We collapse into our own small worlds of routines and worries. But when you remember the scale of the universe, when you stand beneath the stars and realize what they are, everything changes. Your problems shrink. Your gratitude grows. You see that life itself, fleeting as it is a miracle written against impossible odds. The lesson of scale is not despair but urgency. If the universe will one day end in silence, if stars will fade and galaxies drift apart, then what matters is now. This moment, this breath, this fragile planet, this fleeting age when the cosmos is still alive with fire. You're alive in the golden era of the universe, when galaxies blaze, when skies are full of light. That is not something to mourn. It is something to celebrate. You are part of a story so immense it spans billions of years, and yet you have the chance to write your own small chapter. Scale does not make you meaningless. It makes your choice to create meaning even more powerful. So as we return from the stars to Earth, remember this. You live on a fragile dot, spinning in a sea of darkness. You are smaller than small, briefer than brief, and yet within you is the capacity to wonder, to love, to imagine, to create. That is what scale reveals. Not that we are insignificant, but that significance is ours to define. The universe is vast. The universe is cold. The universe will not remember us, but we are here now, alive in its blaze, and that is more than enough. After everything we've seen, the planets and their storms, the stars burning across time, the spirals of galaxies, the invisible hand of dark matter, and the haunting silence of the universe's fate, it is tempting to think the story is finished, that the final chapter has been written and all that remains is to close the book. But the universe is not a book. It is not a tale with a beginning, middle, and end written for our understanding. It is something greater, something beyond story, beyond imagination, beyond even the reach of light, and yet somehow, in this immeasurable immensity, we have found ourselves not only alive, but aware. That is the true ending, not the silence of the universe, but the astonishment of knowing we are here to see it. The scale of everything we've explored should, by all accounts, crush us. The sun is a small star in an average galaxy, one among hundreds of billions. The Milky Way itself is just one galaxy among trillions. The observable universe is 93 billion light-years across, and beyond that lies the unreachable infinite. And one day, long after stars and galaxies are gone, the universe will fade into cold and dark. That is the story the numbers tell, and yet here we are, fragile beings of dust and water, staring at the stars and demanding to know why. If the cosmos is indifferent, then our awareness of it is the ultimate act of defiance. We refuse to be nothing more than passengers. We name the stars, we measure their distances, we dream of reaching them, even if we never will. And in that dreaming we carve meaning into a universe that does not hand it to us. What this entire journey shows is not that we are insignificant, but that significance is a choice. The stars do not care, galaxies do not notice, black holes do not judge, but we do. We care enough to ask questions that stretch across billions of years. We care enough to send fragile machines into the dark, hoping they will whisper back to us. We care enough to write music, paint art, tell stories, love one another, all against a backdrop so immense it could erase us in a blink. Meaning is not given from outside, it is created within. And the act of creating it in a universe so silent, so vast, so cold, that act itself is extraordinary. If you think about it, the universe has already written itself into you. Every atom in your body was forged in stars. The oxygen you breathe was born in stellar furnaces. The iron in your blood, the calcium in your bones, the carbon in your skin, all of it was created in supernova, scattered across the galaxy, and then woven into your form. You're not separate from the universe. You're the universe, become aware of itself. For billions of years, the cosmos unfolded without witnesses. Stars lived and died with no one to see them. And then, on one small rock orbiting one small star, awareness bloomed. The universe began to look back at itself, to question itself, to marvel at its own scale. You are that awareness. You're the way the universe dreams of its own existence. And this is why the conclusion is not silence. The conclusion is now. Because while the universe may one day end in darkness, we live in its age of light. We exist in the golden span when galaxies blaze, when stars fill the sky, when planets orbit suns, when life has emerged. Against the immensity of time, this is a brief moment. But it is our moment, and the fleeting nature of it does not diminish its beauty. It enhances it. The sunrise is more beautiful because it does not last. The universe is more beautiful because it is temporary, and our lives, measured in decades, are more beautiful because they too are fleeting. So what should you take from all of this? Not despair, not insignificance, but perspective. The petty divisions that consume us, the arguments, the borders, the wars, all of them shrink against the cosmic backdrop. They are storms in teacups, distractions on a world that itself is a speck. When you understand scale, you understand fragility. And when you understand fragility, you understand responsibility. Earth is not just a planet. It is a miracle. It is a lifeboat in an endless ocean, carrying every story, every dream, every life that has ever existed. To waste it, to destroy it, to take it for granted is to ignore the rarest treasure in the universe, and beyond responsibility, there is wonder. To look up at the night sky is to step outside yourself, to remember that you are part of something bigger, that your problems, while real, are not absolute, that your life, while small, is not meaningless, that your existence is the rarest of chances, a flash of awareness in billions of years of silence. When you see the stars, you're not seeing something distant, you are seeing yourself, reflected back through time, because you are stardust. You are the universe made flesh. You are the cosmos aware of its own immensity. The final truth, then, is this. The universe does not need to give us meaning, because we give it meaning. The silence of the stars becomes music when we name them. The emptiness of space becomes wonder when we explore it. The inevitability of death becomes beauty when we live fully in spite of it. The cosmos may one day fade, but in this moment, in this fragile age of fire, it blazes with us. And if we choose to see it, to honour it, to live with awe and gratitude, then we have done what no star, no galaxy, no black hole can ever do. We have given the universe a voice. So when you step outside tonight, look up. See the Milky Way arcing overhead, the faint glow of Andromeda in the distance, the endless night stretching in every direction. And remember, you're not looking at the sky, you're looking into infinity. You're seeing across time itself, and you, impossibly, are alive in the middle of it. That is not small. That is not meaningless. That is the greatest miracle of all. Even though we've traced the universe from its fiery birth to its possible silent end, the story doesn't really stop there. Because the story of the cosmos isn't only about stars, galaxies, or even fate. It's also about us, the ones who dare to tell it. For all the equations, for all the telescopes, for all the data, the universe would be nothing more than an endless stage without an audience if not for the fragile miracle of awareness. The ultimate meaning of all this exploration is not locked in distant galaxies or black holes, but right here in the fact that we can imagine them at all. We are the narrators of creation, and our voices are small but defiant against the infinite dark. Think about it this way. For billions of years, the cosmos unfolded without consciousness. Stars were born and died in silence. Planets spun endlessly around their suns. Galaxies collided in displays of unimaginable violence, yet there was no witness, no mind to marvel, no voice to say, "I see." Then, on a small world orbiting a middle-aged star, chemistry became biology, biology became intelligence, and intelligence began to look outward. Suddenly, the universe was no longer silent. Through us, it gained eyes to see itself and words to describe itself. When you whisper the names of constellations, when you chart the path of planets, when you ask questions about infinity, you are giving the cosmos something it did not have before, awareness. And maybe that is the true secret behind all the scale we've explored. Maybe the universe is not vast to make us feel insignificant, but vast so that awareness, once it arrived, could find something worthy of its wonder. If everything were small and simple, if the cosmos were just a few lights in the sky, maybe our curiosity would have run dry long ago. Instead, we are confronted with a canvas so immense it demands endless questions, and every time we answer one, 10 more arise. Why is there something rather than nothing? What lies beyond the observable universe? Are there infinite versions of us playing out infinite stories? These questions may never be answered, and that might be the point. The mystery itself keeps us alive, keeps us reaching, keeps us refusing to accept the limits of our smallness. It also connects us to one another in ways we rarely recognize. When you stand under the night sky, you see the same stars your ancestors saw. Ancient civilizations built temples, aligned monuments, and told myths based on the constellations we still recognize today. They didn't have telescopes, they didn't know about galaxies or black holes, but they felt the same awe we do. That awe is a thread that runs through all of human history, binding us across time. The cosmos doesn't just connect us to infinity, it connects us to each other, across cultures, across generations, across centuries of searching. In that sense, the universe has always been more than physics. It has always been a mirror for what it means to be human, and yet, for all our achievements, for all our knowledge, we remain humble beginners. We've only just stepped onto the stage. Our probes have reached only the outskirts of our solar system. Our telescopes capture light from ancient galaxies, but they cannot touch them. We dream of travelling to the stars, of building civilizations among the planets, but for now, we are bound to this one fragile world. That should not discourage us. It should inspire us. Because even from here, even without leaving Earth, we have already reached into infinity. We have measured the age of the universe. We have mapped the shape of its expansion. We have glimpsed the afterglow of creation itself. From one small rock, using fragile instruments built by fragile hands, we have stretched our awareness to the very edge of time. That is nothing short of miraculous. And the story isn't finished. Each generation pushes a little further. Today we search for exoplanets that might harbour life. We send rovers to Mars, telescopes into orbit, detectors into deep mines. We listen for signals in the cosmic background, hoping to catch whispers from dark matter. Tomorrow, who knows? Maybe we will build engines to cross the stars. Maybe we will harness power we cannot yet imagine. Maybe we will discover that we are not alone, that life has bloomed elsewhere under alien suns. Or maybe we will find only silence, and in that silence realize how rare and precious our existence truly is. Either way, the journey will continue, because asking is what we do. Asking is what makes us human. And perhaps that is the final meaning of Section 15, not the end of the universe, not even the conclusion of a story, but the continuation of a question. We don't tell these stories to reach a final answer, we tell them to keep wondering, because in wonder we find purpose, in wonder we find connection, in wonder we find courage to face the silence without fear. The universe is vast, yes. The universe is indifferent, yes. But we are here now, breathing, thinking, dreaming, and that is enough. So when you next look up at the sky, don't just see stars, see yourself, see your ancestors who once traced shapes in the constellations, see the future generations who will carry our questions forward, see the atoms of your body, born in fire, shining back at you through the light of suns billions of years away. See not just distance, but belonging. Because the universe is not out there. It is in you. It is you. And your awareness of that truth may be the rarest phenomenon in all of creation. If the cosmos truly ends in silence, if heat death swallows everything, if galaxies drift away and stars burn out, then your life, here and now, is the fire that resists the dark. You are the flicker of meaning in an indifferent void. You are the miracle the universe didn't know it was capable of producing. And if that isn't enough to make you feel infinite, nothing ever will. When we step back and take in the entire journey, from the birth of the universe to its possible silent end, from the vastness of galaxies to the fragile breath of human life, the most important truth isn't hidden in equations or telescopes, it's hidden in perspective. The universe is immense beyond measure, and yet here we are, alive in the middle of it, aware enough to ask what it means. That awareness is not trivial. It is the rarest spark in a cosmos that otherwise moves without witness. For billions of years, stars were born and died in silence, galaxies collided in darkness, and time passed without memory. Then, for reasons we may never fully understand, consciousness emerged on a small blue dot orbiting an ordinary star. And from that moment forward, the universe began to see itself. That is what makes this story extraordinary. Not the stars, not the galaxies, not even the vast emptiness between them, but the fact that we, made of the same atoms as those stars, can look up and wonder. Every time you trace a constellation, every time you dream of distant worlds, every time you marvel at the night sky, you're participating in the greatest act of defiance imaginable. You're giving meaning to a universe that does not hand it to us. The cosmos is indifferent, but we are not. We love, we grieve, we create, we search, and in that searching we make our lives significant. The conclusion, then, is not despair, but gratitude. Gratitude that in all the immensity of space and time we exist at all. Gratitude that we are alive during the golden age of the universe, when stars still burn and skies still blaze. Gratitude that we can share stories, build connections, and carry questions forward for generations that will continue long after us. The universe may one day end in silence, but today it is alive with light, and so are we. So the next time you look at the night sky, remember this: you're not staring into emptiness, you're staring into a mirror. The atoms of your body were born in those stars. The light you see has travelled across billions of years just to reach your eyes. You are part of that story, inseparable from it, a fleeting but miraculous expression of cosmic history. And though the universe may not remember us, that does not matter. What matters is that we are here now, breathing, feeling, asking, daring to wonder. In the end, that is enough.